Um, Hi, welcome to my YouTube channel. I am going to go through all of physics as outlined by the AP Physics unit order, which is decidedly not all of physics, and then after that I'll just bounce around and talk about topics I like, which will also not be all of physics. But I'm a physics major, and I thought this could be fun. I'll go through and I'll make either like videos by unit, or I'll make different videos and put them into folders for like unit 1, unit 2, and that so on and so forth. But basically, the first thing that physics really tries to define is movement. And to define movement, it's important to know about three things, which is position, velocity, and acceleration. So position, I'm assuming this one doesn't require a ton of explanation. It's just, where is it? Where it be? Where is it at? So position can be positive or negative. Basically, you have like some starting point, and it's the distance away from that starting point is how I think of position. So if there's a wall and that's like your point 0, and you're thinking of position as like just horizontal, like on the x-axis, then if something is 2 meters in front of it, then it has a position of 2 meters, and if it's 2 meters behind it, then a position of -2, something like that. And so, oh, I almost clicked exit. Velocity, how fast? Velocity is just the change in position over change in time. So it's the concept of speed, but now it has direction. So it not only is it how fast is it going, but how fast is it going and in what direction. So that adds a positive or negative element to it. Is it going in the negative direction or the positive direction? Or sometimes there'll be different things with components, but we'll get into that later. For the first part of physics, it's really thinking about things super linearly. And honestly, it's still later on a lot of just easy, like, oh yeah, forward, backward kind of stuff. But the standard unit for it is meters per second, because again, it's the change in meters per second. So acceleration is the change in velocity. It's the change in velocity over change in time. So you take that meters per second and you put it on top of another per second, and it turns into meters per second squared. It can also be positive or negative. Positive and negative is, completely arbitrary. It's just whatever you define as positive or negative, like for directions. So if you have a velocity that's staying constant, so if I have a velocity that's 1 meter per second, then my acceleration is also going to stay constant right at 0. But if my velocity is going up and is positive, then I'll have a positive acceleration. Going down and positive, then it'll be a negative acceleration. I'll explain this all graphically a little bit later, but basically all you need to know right now is that acceleration is the change in velocity over time, and so how fast is it speeding up or slowing down, and then the velocity is, change in position over time, and position's position. Okay, so if we have this graph, position in meters and time in seconds, made it on Desmos. I couldn't figure out how to get rid of that without cutting this off. I almost added a bunch of like little gobbledygook down here so I could just like cut off some letters. It doesn't matter. So you can see that this object is moving 1 meter per second, because every time that it goes up 1 meter, it goes over 1 second. Velocity is basically the slope of your position graph. So if we were to take the slope of this position graph, position versus time graph rather, at every point in time it's going to be 1. So our velocity would be graphed like this, just a horizontal line right at 1. Because at any point in time on this graph, since the position is changing like a constant rate, our velocity is constant. So it's right here at 1. Our acceleration is also constant then, and it's going to be a horizontal line at 0, because there is none. Velocity, not change. Acceleration, not change. And so there's some other graphical relationships that I want to talk about. So 1 second. I'll get out of this and then go into a different thing. Okay, so I have opened up Paint in order to draw some graphs and show like the general relationship between velocity, acceleration, position, all that good stuff. So if I had a graph here, here, and here, and this was They're all going to be time. One second. Okay, so that'll be position versus time. This will be my velocity versus time, and then this will be my acceleration versus time. I'm going to show you the general shape of the graphs. So if I had a position that was going up, and this is supposed to be like a straight line, then we know that my velocity would, hey, that's not good. Is there like a line tool? I'm not well versed with, heck yeah. Okay, we're bougie now. Little straight lines. So if I had a position going up like this, with respect to time, it's going to be the exact same example that we were talking about previously, but now I actually have the graphs of velocity and acceleration to show you. Then I would have a constant velocity and a constant acceleration. So if you know anything about derivatives or integrals, which you don't have to for AP Physics, but if you're not, if you know, basically velocity is the derivative of position and acceleration is the derivative of velocity. And for those of you that don't know what derivatives or integrals are, velocity is the slope of position at any point in time, and acceleration is the slope of velocity at any point in time. So you can see that this graph is a slope of 0, so acceleration will have a slope of, not a slope of 0, but like an amount of 0 at all given points. And this has some slope, so this is going to have that. Okay, so moving on. What does this do for me? Heck yeah. Okay, so if my position is going up, and this is supposed to be some sort of exponential graph, it's not really because of that, but I don't know. Pretend that this is exponential. So if position is going up exponentially, that means that the position with respect to time, like the change in position with respect to time, is going up and up and up and up. Which means that if we have like an exponential graph, that our velocity is also going to be going up and up and up. Because this isn't just some straight line with some straight slope. If we were to take the slopes at any given point in time, they should be getting higher and higher. So that's why the velocity graph would look like this. And then the acceleration graph in that case would just be a straight line. Okay. So if instead of an exponential graph, if it had more of like a logarithmic, yes, perfect. Okay, if it had more of a logarithmic growth look to it, so as time goes on, the change in position over change in time is going down. So we started with some initial, velocity, so we're going to start up here, and then it's going to go down till it's almost to 0, and it's just like a straight line across, and there's no change in position. So in that case, my velocity graph would look something like this, and my acceleration graph would actually be a straight horizontal line, but now in the negative, because now there's a constant negative slope for my velocity. So that's how you would do that. Yeah. So I think that's all I'll do for this one. Bye.